Okay, let's talk about probability, which is just the likelihood that some event occurs. Right? You might wake up in the morning and go, okay, what's the probability it's gonna rain today or be cold today? Grab a jacket or whatever. So weather, like I got here, rain. What's the probability that you have the winning lottery ticket and you win the Mega Millions? Probably pretty low, but there's still a probability associated with it. Or any sort of like raffle entries that you might enter in. I don't know. But probability, we typically talk about it in terms of percentages, right? There's a 60% chance of rain today, or fractions, right? You have maybe you don't see that as much, but you can convert percents to fractions, and fractions to percents. So they're all one and the same, and decimals too. So all those three things we use to represent probabilities, but more so we probably use percentages than the other two. Here's a formula for probability, or determining the likelihood of some event occurring. And it is this right here. So the probability of an event occurring, which we write it like that, is equal to the number of favorable outcomes divided by the number of total possible outcomes. And we'll do an example here in a second. Actually, let's just do it now. Let's say you have a box, and inside this box you have some green marbles, you have some orange ones, you have a red one, and then maybe 3 purple ones. And we want to know, scroll down here, we want to know what's the probability of drawing a purple marble. So you're going into the box, you're grabbing one marble, we want to know what's the probability that it's going to be purple. Well, let's use this formula we have right here. So what are the favorable outcomes? The favorable outcomes are if we grab this one, or this one, or this one. So there are three opportunities, or 3 marbles in there that are purple that are favorable to this specific outcome. So there's 3 favorable outcomes. Again, I can grab this marble, this one, or that one because they're all 3 purple. Well, how many possible outcomes are there? Well, that's just the number of marbles we have in this box, because I could grab this green one, or that green one, or that green one, or that green one, or that red one, or that orange one, or that orange one, or any of those 3 purple ones that we talked about before. So those are all the total, all the possible events that could happen when you put your hand in the box to grab a marble. So count those up. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability that you pick a purple marble is 3 out of 10. Or if you want to write it as a decimal, that would be 0.3. Or as a percentage, which would make probably the most sense, it would be 30%. A couple other points about probability. The first one is that probabilities have a value that's going to range between 0 and 1. Or if we want to think of it in terms of percentages, it's going to be between 0% and 100%. There's no such thing, or it doesn't make sense if someone says there's a 200% chance of rain today, unless they're trying to be like sarcastic and say that it's definitely going to rain. That doesn't make sense. So again, maybe you've seen this a couple of times from watching my videos. If you're not watching my videos, you definitely should. But here, we'll look at that left side of that inequality, which is 0 is less than p, or if we read it right to left, that says p is greater than or equal to 0. So the probability has to be greater than or equal to 0, or greater than or equal to 0%. And then this part over here, p is less than or equal to 1. We can read that left to right, and it says that the probability of something happening has to be less than or equal to 1, or less than or equal to 100%. Another note about probability, we got theoretical versus experimental probability. So theoretical is what is supposed to happen on paper. And then experimental is actually what happens in real life, because there are other variables that we might not take into account of when we're doing theoretical calculations. So we'll do an example here real quick. I got a coin here. Let's see here, George Washington vibes, and on the back, what do we got? I think that's South Carolina. So if I flip this coin and I want to know, I'm going to flip it 4 times. So what's the probability that I get tails, let's say, of those 4 flips? Well, theoretically speaking, if I'm going to flip it 4 times, right, 2 of those should land on tails because it's a coin. You have a 50-50 shot of getting heads or tails. So 2 tails out of 4 throws. Again, 50-50. Gonna have to be 2 tails and 2 heads. We're just talking theoretical. Now let's actually do a quick experiment and see if that's what happens. So there we go. First one is tails. So you know that I'm not lying. Tails. So we'll put tails and heads here. So I got a tails. Do it again. We got heads. And another one. Heads. And whoops. Heads. So what happened? Why did I only get 1 tail out of 4 throws? It should be 50-50 because you're just flipping a coin, right? Well, the fact that we conducted this experiment shows that that's not always going to be the case. But if you do a bunch of throws, like let's say you did 100 or 100,000 coin flips, it's going to average out to 50-50. You know, some cases you'll have like a bunch of heads in a row, and then you'll have a bunch of tails in a row, but it's all going to average out. So the more throws that you do, or the more trials that you run, you're going to see the experimental probability approach and be the same thing as the theoretical. So there you go.